Today our aim is to be able to determine if two shapes or two figures are congruent. Whether they be two-dimensional shapes or three-dimensional shapes, doesn't really matter. Today we're focusing on two-dimensional shapes. But even before we get started, we need to talk about a little bit of notations that we will see mathematically when it has to deal with geometric figures on a page and things with comparing them. So when we're looking at this, this first part is just talking about tick marks on lines. So a lot of times you'll see a shape drawn, as you can see some on the right-hand side of the page, that have these tick marks on the lines. Those tick marks are just representative of a relative size. It's not telling me that this is, because it has one tick mark, it's not telling me that it has, it's 1 inch long or 1 centimeter long or 1 mile long or 1 foot long. It's just saying this is a certain length. Any other line segments on this page that have one tick mark are the same length. So, which other line segment other than AB is the same length? Whitney. CD. Now, on the same token, if it has a different number of tick marks, that is telling you that it is a different size. Therefore, we have two line segments down here with 2 tick marks, meaning that they are both different sizes than the ones with the 1 tick mark. However, EF must be the same size as GH, because they both have the same number of tick marks. So, coming down here, just some more notation about this. When you're dealing with line segments, you'll find that line segments are usually identified by the 2 endpoints of the line segments written out with a line over the top of it. Okay, that little line over the top of it is telling you that it's talking about a line segment AB. Okay, just a little bit of notation. That's not part of our lessons for today, but those are things that you're going to see as you move forward in your math career and as we move forward with some more geometry. They pretty much do the same thing with angles. The only difference is when you have an angle, it's hard to identify where that angle is. So they draw a little arc across the angle so they can put the tick mark on to identify the angle. That way they're not trying to cram little tick marks down on the angle like this. That's really, really confusing. So they put this little arc on there so they can identify with tick marks. So with this, it's the same thing. If it's got 1 tick mark and 1 tick mark, those angles are the same size. If it's got 1 tick mark and 2 tick marks, that means those angles are different. Okay. Just same thing with the notation down here. You're going to see that instead of putting a line over the top of it, they put a little angle symbol right next to it. And really important about angles is that you're able to read them. They go in order from one of the outside points to the vertex, and back to the other outside point. If they try and label this same angle, and I were to say angle CAB, that's a completely different angle because it's going from C to A to B. Those are not the same angle. So with angles, it's really important, Monique, that you are able to get it in the right order. Otherwise, you're talking about a completely different angle. The vertex always has to be the middle letter. Okay? Does it matter if I do ABC or CBA? No, that's the same because it still has the same vertex in the middle. Okay? So that's that. That's just a little bit of notation that you need to know. That'll help us move forward with our work for today. When we're talking about congruent figures, does anybody know what congruent means? Jasmine. the same. And very specifically, when we're talking about the same, there's two ways we're going to talk about the same. Let's come down and actually talk about some things that are clearly not the same. Looking at these first two shapes, how do I know these are not congruent? Not the same. Jasmine. Right, so these are not congruent. Because they have a different number of sides. Different number of sides. So they're obviously not the same. Now, looking at the next two. These are also not congruent. How do I know these are not the same? Not congruent.
Different sizes.
Luis.
Because they both have different sizes.
Yeah, they're different sizes. So these are not congruent. Because they have different sizes. So one way we know that they're different, even though they have all the same angles, 45, 90, 45, 45, 90, 45, even though they have all the same angles in the same order, Alyssa, we still know they're different because if we look at the lengths, there is a 5 on this one and no 5 over here on the other one. Okay? Looking at the next one, how do I know these two are not congruent? What makes those not congruent, Monique? They're different shapes. More specifically, how can we see that they're different shapes? That has to do with even more specific mathematical language, Richard. They have different angles. Okay, so we know these are not congruent because they have different angles. So if we want to determine if two shapes are congruent, there's two specific ways to talk about it. We said that they have to be the same. And specifically, we're talking about the same size and the same shape. So same size, we're talking about the lengths. And same shape, we're talking generally about the angles. So the way that we can check in on whether two things are congruent or not. Next page. One way that we can check in on whether they are congruent or not is by simply going through and figuring it out. So these are the same, we've got to figure out if they're the same size. One thing about geometry is that this is kind of the story that I tell about geometry, and when you get to geometry class in high school, is I kind of use this story to kind of equivalate to how your geometry is going to be. So I go buy a brand new pair of Nikes. I go home, I take them home. I set them on my doorstep really quickly. I go in and have a glass of water. I come back out 5 minutes later. Shoes gone. Okay. Next day, I'm walking around my neighborhood and I see this guy wearing the same pair of shoes that I just bought. But I don't have anymore. His look relatively new. But my intuition says he took my shoes. However, I have no evidence. I cannot prove it. in the end, since there's no witnesses and there's nothing to go around with it, it's my word against his. Because if I go up to him and I say, hey, where'd you get those shoes? And he says, I bought them.
Check your receipt.
Then I have no proof. Okay? So I cannot prove that. And that's a lot about what geometry is all about. When you get to geometry class, everything is going to be like, you can have these intuitions, you can have these ideas, you think things can look a certain way, but your geometry teacher is going to say, that's great, prove it. And that's what geometry is all about. And I think that's a really big struggle for a lot of students, because everything in middle school is so like, it is the way that it looks. And you're just like, I'm accepting it. It looks like they're the same, so they must be the same. Your geometry teacher is going to say, prove it. And so when we're talking about some of the stuff that we're going to do here with congruency, we're always going to be talking about being able to prove it. So when we look back here at these two problems here where we're trying to determine congruency. This first one says, are they congruent or not? So this first one, give me a kip yes if these two shapes are congruent. Give me a kip no if they're not. No. Obviously, not congruent. So you're going to be very able to write down not congruent. And now you're going to have to prove to me, how do you know that? Jasmine. Yeah, they have different sizes. So for them to be congruent, if this shape has a side that's length of 2 centimeters, this shape over here would also have to have a side somewhere that is length of 2 centimeters. One way that you can go about it is you can always just write in order, start at one point and write in order the lengths of the sides. So I see 2, 3, 3. And I would have to be able to start somewhere here and have 2, 3, 3, but I don't. So 4, 6, 6 tells me that they are different sizes. Right? Looking at these next two shapes. Give me a kip yes if they are congruent, a kip no if they are not. Okay, I see a little bit of disagreement here. I see mostly yeses. So if we believe these are congruent, then we have to be able to prove it. Okay, so the way that we're going to be able to prove it is we have to determine that they are the same size and the same shape. So the way that we're going to do that is we're going to start just like we did with the last one, and we're going to pick a point, and we're going to go across all of the sizes. So 5, 4, as I write them down. Wait, what about this one? This one's not labeled. It's 5 because what? Same as the top, because it's a parallelogram. 5, 4, 5, and this one is 4 because it's a parallelogram. Alright? We also are going to check in on the angles. The angles should be 60, 120. Wait, this one's not labeled. Your geometry teacher is going to say, prove it, and you're going to say, oh, I know the opposite corners of a parallelogram are 60. And then this last one should be 120, and your geometry teacher is going to say, prove it, and you're going to say, the opposite angles of a parallelogram are the same. So we're going to have to be able to follow this same pattern over here of 5, 4, 5, 4, and 60, 120, 60, 120 over here to prove that these are congruent. So I can go 5, 4, And then I would have to go 5. Is this 5? How do I know this is 5? Opposite sides of parallelograms are congruent. And this last one would have to be 4. Is this 4?
Yes.
How do we know?
It's not.
Opposite sides of a congruent. So far, so good. Alright, so now I also have to be able to go 60, 120, 60, 120. Well, I only see a 120 down here. I guess I know opposite sides are congruent. That leaves me these two pieces here, which if we're doing 360 minus 120 is 240, minus another 120 would be 120. Since it's a parallelogram, these two must be the same, so what two things can I add up to get 120? 60. So can I follow I can follow 60, 120, 60, 120 pattern just like I could over here. So, you just proved to me because they are the same size, they have the same lengths, and the same shape, they have the same angles, that they are congruent. Now, your geometry teacher is going to say one thing to you. She says, that's great and all, but you made the assumption that these are parallelograms. How do you know those lines are parallel? And then you're going to want to light your geometry teacher on fire. But I'm not your geometry teacher, so I'm going to say, I'm going to let you assume that those are both parallelograms. So we're good. These are congruent. So we knew that what was left over between these two angles was 120. So if we had two angles that were the same, that add up to 120. So we basically divided by 2. We got 60. All right, and now let's look at this last one. This one is missing some angle information. But one of the great things that your geometry teacher is going to tell you, / I am going to tell you, you can just leave it on the desk up there, is that with triangles, as long as all of the lengths are the same, you will know all of the angles are the same. So with triangles, all we have to prove for congruency is that they are the same size. So, I see two triangles here. It says ABC, so ABC. And it's looking for me to compare that to ADC. So, I need to find the lengths of my sides of the triangle. So, the length of this side is what? It's 1 tick mark, right? I don't know what 1 tick mark stands for, but it's 1 tick mark. The length of this side is 2 tick marks. And the length of the third side, it's not labeled, so we're going to have to go ahead and label it. We can label it X, we can put our own tick marks on it, so I'm going to go ahead and put 3 tick marks on it and say, I don't know what that is, but I'm going to call it 3 tick marks. Now, I have to prove that if I think these are congruent, that the blue triangle has the same length sides. Well, the blue triangle I see has a length of 1, a length of 2, and a length of, hey, look at that, we already labeled that one. We labeled it as 3, so that one's a length of 3. So sure enough, these triangles have the exact same length sides. So that means the triangles must be congruent. Your geometry teacher is going to probably step through and make you prove that this angle is the same as this angle, and this angle is the same as this angle, and this angle is the same as this angle. I'm not going to make you prove that. I'm just going to tell you special case for all triangles. For all triangles, if the angles are this, or excuse me, if the sides are the same, the angles have to be the same. Okay, that's true for triangles. All right.